Hi guys. So it's Sunday afternoon and I was able to take a look at some of the homework problem sets that a few students have submitted early, and I wanted to make a video that covers the concepts that the textbook talks about in chapter 0.2 a little more in detail. So I thought the textbook did a good job just briefly introducing the basic concepts of the first part of discrete math, but hopefully this PowerPoint presentation will get us a little deeper. Okay, so it starts with the conditional statement, and what that is any statements in the form if P, then Q. So the symbol for the mathematical symbol for that statement, something if, then if and then statement, is this right-sided arrow. So in English, if we have if P then Q, in mathematical language, we just have this P, right-sided arrow, Q. So for example, let P represent the statement you drink Pepsi, and let Q represent the statement you are happy. So in this case, this P right-sided arrow Q simply means the statement in English, if you drink Pepsi, then you are happy. You drink Pepsi is called the antecedent. Also for the science world, it's called the hypothesis. And you are happy is called the consequent. It could also be called conclusion or the outcome. All right, so let's do an example. Let P be the statement, it rains, and let Q be the statement, I stay home. Symbolize each statement. If it rains, then I stay home. So this would mean if P, because P is the statement that it rains, then I stay home, just like that. Number 2, it is not the case that if it rains, then I stay home. So what I first notice is this part of the sentence, if it rains, then I stay home. That's really identical to number 1. So I'm going to start with that. If it rains, then I stay home. What's different from number 1 is that this entire statement is negated with the word not. And this word not in mathematical language is this symbol right here. All right, sometimes in other textbooks it's also used as this symbol, so you guys can use one of these two. If I don't stay home, then it doesn't rain. So stay home, I stay home is Q, but it has to be negated because it's not. So if I don't stay home, that's not Q, then it does not rain. So it rains is this P, so it does not rain. So that's going to be our mathematical statement. Number 4, it is not the case that if I stay home, then it doesn't rain. So again, I'll take a look at that statement first. If I stay home, that's Q, then it does not rain, so I want to negate P. And pretty similar to number 2, this statement has been negated, so I'm going to negate the whole thing, and there we go. So we have some plain English statements and mathematical statements. Okay, so this is the part that I was really worried that the textbook didn't really cover, so here we go. Okay, so direct statement, we're working with some statements. We're just starting with just 2 statements, if something P, and another, the second statement, Q. So what we have is we can have some cases. We could have a case where the statement P can be true. We could be working with a true statement, and also Q statement being true. There could also be the case where P is also true, but Q is false. Third case is when P could be false, but Q is true. And last case is when both of these statements are false. Okay. All right, so that runs out all of our possibilities. And now what I wanted to go over is let's take a look at our direct statement if P, then Q. All right. So this is the part where we're going to develop some logic in mathematics. So let's first start with our first case where P and Q are both true. So if true, then true. Is that, as a whole statement, is that true? If our hypothesis is true and our conclusion is true, and I think as most of you guys can guess it, this is a true statement. Okay. All right, so let's take a look at the second possibility where P statement is true, but Q is false. So we are somehow starting with a true statement, true hypothesis, but our conclusion ended up being false. And as a whole statement, this is a false statement. It's expected that if we're starting out with something true, then it's expected that we're ending with true, just like our first case. All right, now let's look at the third case. Our hypothesis is false, but somehow our conclusion ended up being true. Okay, so when we're doing science fair experiments, what's more important? Our hypothesis is important or our conclusion is important. And I think any kids who are working on their science fair project can tell us that, oh, it's the scientific outcome is what matters. So our hypothesis can be true, or we can miss our guessing, and it could end up being false. But as long as our outcome ended up being true, we're happy, and this statement is going to be a true statement. Okay? And the last case, if our hypothesis is false, then it's generally and we're sure about this hypothesis, then it's generally it's expected that we're going to get a false outcome. So therefore, this statement is also true. Okay. When I first learned this, it was a little confusing. So, but over time, with lots of practice, it'll settle in. So don't worry if you're not following this entirely. Let's do more practice. This time, let's do the converse. So converse is just the same thing as direct statement, but flipped. So now we're working if Q, then P. Okay, so we're starting, our Q's are now our hypothesis and our P's are our conclusion. So let's start here. If true, then true. And this is pretty easy scenario that we can think of, then this is going to be a true case. All right, so what if our statement is false? We're starting with a false statement, but somehow ended up with a true outcome. And again, our outcome is the one that is important. So in this case, this statement is going to be true. Okay, so if true, then false. We started out with everything being correct, but ended up with the false outcome, something not working. So this statement is false. And again, our outcome is the one that we want to pay more attention to. And it's as long as everything went right, then it's expected that our outcome is also true. Last case, if it's expected that everything goes wrong, then our outcome says everything went wrong. And this entire, as a statement itself, this is a true statement. Okay, so that's what we have. Now let's take a look at inverse and contrapositive. So if you guys look closely, inverse and contrapositives work with the negated statements of P and Q. So let's make those. So negation of P and negation of Q. So we're just going to flip everything. So true now becomes false. Also true becomes false, and true, true. Okay, so true becomes false, true, false, and true. Okay, now let's do inverse if P, then not Q. I'm sorry, if not P, then not Q. All right, so we're going this way, correct? So if false, then false. That's a true statement. If false, then true. Again, outcome is the one that is important, so this is going to be true statement. If true, then false. This is going to be a false statement. And lastly, true and true, this is true. All right, that's what we have. And lastly, our contrapositive, not Q, then not P. So we're still working with these two statements, but now we're going backwards. So if false, then false. This is true. If true, but false. So this is going to be a false statement. And if false, but somehow our outcome ended up being true, so we're happy with that true outcome. And lastly, true. If true, then true. So that's going to be true. Okay. So what you guys notice here is, please note, let me pick a different color. Okay, so this is the direct statement. This was the converse, inverse, and contrapositive. Converse. Okay, so take a look, and what results ended up being same? That meaning TFTT, TTFT is not the same. TTFT, again, is not the same as TFTT. But now take a look, contrapositive, TFTT. So these two are identical. So that's a pretty important note going forward. The direct statement is always going to be exactly the same thing as the contrapositive. So which means that if we are working with a true case, then the contrapositive of the same, working with the same statements is also going to be true. And likewise, if the direct statement of P and Q are false, then contrapositive of the same P and Q will also be false. Okay, but we're going to talk about that more in upcoming problems. All right, now let's take a look at some examples since we've done all the proofs. So just more examples. Direct statement, if you drink Pepsi, then you are happy. Again, this is if P, then Q. Converse is just a flip of P and Q. If you're happy, then you drink Pepsi. So this is if Q, then P. Inverse is if you don't drink Pepsi, then you're not happy. So from the direct statement, we're just negating each of the statement, but the order stays true. So that's what it looks like. And contrapositive is if you're not happy, then you don't drink Pepsi. So if not Q, then not P. And again, please note that as we've seen in our proof, direct statement and the contrapositive, these are always going to have the same value, result value. Either the statements are going to be either true or false.